Hello students and welcome to Foundations. Or as we also call it, um, Math 104. And of course we could put foundations under logic, but what we're only doing is applying logic to it. This is mostly on the mathematics part of constructing stuff and of course building the theory from the ground up. So in foundations, the main goal is to build the theory from the ground up. So all the concepts that that you guys see in LOSC, in the math parts of LOSC, is all gonna be based off of what we're gonna discuss here in foundations. Now with foundations, we will be using a variety of concepts from set theory and other parts of mathematics. An example of that, an example of what we're going to discuss or what we're going to use here in foundations is, of course, we're going to use set theory. We're going to use set theory. So the concept of sets, construction of sets, various axioms and systems or axiomatic systems. So yeah, we're going to be using set theory. That's one thing we're going to use. We may also employ some use of modal logic, especially the multiple worlds interpretation of models and stuff, as well as the operators, the diamond and the square, perhaps. Though we're not certain if we're actually going to use this. This is a new course that we've started, so I thought to myself, okay, so right, we have all the theories, that we have all of the stuff, all of the mathematics, but what is the bedrock of it all, right? In modern mathematics, we don't just do the math, okay? Especially pure mathematics, we don't just do the math. We don't just prove the theorem. We don't just construct the conjectures. We don't just assume the assumptions themselves without some solid basis for everything. So that is what all of this is. And with foundations, of course, we would also require some other concepts, maybe perhaps abstract algebra. There's a chance we might use abstract algebra. Of course, when we talk about the ZFC, of course, in our fempoization of it, or putting it into the context of person theory, we want at least some notion of groups, or we're going to need at least some notion of groups when we talk about the Banach-Tarski paradox, and of course a sketching of it. Now, of course, the Banach-Tarski paradox is not going to be mostly focusing on the abstract algebra itself, but it will be focused, or our discussion of it, at least in this course, would be focused on the application of logic and the Zermelo-Fraenkel set theory, I think, or Zermelo-Fraenkel axioms with the axiom of choice, ZFC basically. We're going to be using ZFC. And when we discuss the Banach-Tarski paradox, we're not going to be focusing on the abstract algebra of it, or the way we actually did it, but we're going to be talking about how the use of the axiom of choice has led us to such a paradox, such a bizarre paradox that we need to accept because of logic. So just a warning, when we do construct our axiomatic systems, there may be some inconsistencies because we will be also discussing about the Gödel incompleteness theorem, which shows that no axiomatic system can be fully consistent or can fully decide the truths of certain statements. So there will be theorems, there certainly will be theorems which we cannot prove. All right. And it's important for us to have a basis so that we can prove stuff from there on out. And of course, we construct the models which the entirety of our math takes place in. So yeah, so abstract algebra, modal logic, set theory. Now we did talk about axiomatic systems a little bit in fembiology, or I forgot the course from. But either way, from fembiology we talked about a little bit of set theory, of course, with constructing stuff, and of course formalizing some things like the Yowie set and the Bussy axiom. So axiom of the Bussy and other stuff like that. We formalize them by constructing a set, and that employs some use of set theory, and we will go in depth here in foundations. So this is the introduction for foundations or math 104. This will involve logic, of course, so you'll also need logic for this, especially when we try to prove some stuff. So first order logic would be a great prerequisite to this course. So I will see you guys in the first lecture.